Okay, today we're talking about Chapter 3, Section 3, Proving Lines Parallel. 3.2, we talked about when lines are parallel, you can conclude certain things. Now we're going to go backwards. So if you have pieces of information about the angles, then you can tell that they're parallel. Your objective is to use the angles formed by a transversal, so still talking about the line that cuts through the parallel line, to prove that two lines are parallel. Again, going backwards. Want you to pause the video, write down your essential question, and then unpause it and come back. First, we need to talk about what converse means. Converse is something that is the opposite of or not. When you put not in front of a statement, it's the opposite of the original statement. That's going to be very important to what we're doing today. Alright, so 3.2, like I said, we talked about corresponding angles postulate. This lesson talks about the converse or the opposite of that. So we talked in 3.2 that if two lines are parallel, then their corresponding angles are congruent or the same measure. This postulate says that if you know that they're the same measure, but you don't know whether or not these are parallel, if you know that they're the same measure, then that tells you that they're parallel. So if angle 1 and 2, the corresponding angles, are congruent, then M is parallel to N. And there's an example over here. So we have these lines. I don't know if they're parallel because they're not marked. They look parallel, but you can't tell. You have angle 5 and 7 labeled here. Angle 5 is 5x plus 12 degrees. Angle 7 is 4x plus 25 degrees. And they also tell you that x is 13. So you can substitute the 13 into the x for both of those angles. Angle 5, when you substitute the 13 in, you get 77 as your answer for that angle right there, 77 degrees. And when you substitute the 13 in for angle 7, you also get 77 degrees. So because both of these angles, which are corresponding, are 77 degrees, now I can conclude that these lines are parallel. There's something called a parallel postulate. It says that if I have any random line L and any random point P, there's exactly one parallel line that I can draw through that point that's going to be parallel to the original. Only one line. So that's that postulate. The next one is converse of alternate interior angle theorem. Yesterday you talked about alternate interior angle theorem. This is the converse or the opposite of it. So it says if I have alternate interior angles that I know are the same measure, then I can conclude that the lines are parallel. I don't know that they're parallel to start with because they're not marked. So if 1 and 2, alternate interior, so they're on the opposite sides of the transversal, but they're on the same side of your, or on the inside of your lines that we're trying to prove whether or not they're parallel, then both of them are parallel if they're the same. Alternate exterior angles theorem, same thing. Opposite sides of the transversal, but now we're talking exterior, so on the outside of the lines that we're trying to check if they're parallel. If those opposite side and outside angles are congruent, then I know that M and N are parallel. Oh, I didn't label them. There's M. There's N. So if these two are congruent, or we find out that they're the same measure, then I know that these two lines are parallel. Last one. I have same side interior angle theorem. So same side of the transversal and on the inside of the lines that we're trying to prove parallel. If 5 and 6, or these two same side interior angles, when I add them equal 180, then I know that these two lines are parallel. If they equal anything else, then I know that they're not parallel. Just like if these two are not the same, then I know that they're not parallel. Alright, so here are our practice problems. A over here tells me that angle 2 and angle 6 are congruent. I'm going to label these so that you can see them a little more clearly. There's my angle 2, and here's my angle 6. If both of those are the same measure or congruent, can I tell that these two lines are parallel? The answer is yes, I can. What theorem or postulate can I use? Well, these are on opposite sides of the transversal, but they're on the inside of those two lines. So it's alternate, opposite sides, interior or angles theorem. Alternate interior angles. That's first example. Second example. So I have the measure of angle 6. We're still using the same image, but we can't carry over the answer from that problem to this problem. So we're still looking at the same picture, but we don't know that they're parallel yet. So measure of angle 6, they tell us, is 6x plus 18. And the measure of angle 7, erase this for the new problem. Now we're talking about 6 and 7, these two here, is 10 degrees. So if I plug in 10, or excuse me, measure of angle 7 is 9x plus 12, and x is 10. If I plug in 10 to both of these, we'll do angle 6 and angle 7. Angle 6 is 6 times 10 plus 18, and angle 7 is going to be 9 times 10 plus 12. 6 times 10 gives me 60, plus the 18. 60 plus 18 gives me 78. 9 times the 10 gives me 90, plus 12. 90 plus 12 gives me 102. Now I have the 78 degrees and the 102. They're not the same, but they're same side interior, so I have to see if they add up to 180. Kind of running out of room. I have 78 plus the 102. 8 and 2 is 10. That's 180 degrees. Because it's 180 degrees, same side interior angles tell me that these lines are parallel because 7 plus 6 is adding up to 180. If you have any questions, write them down. We can answer them in class. Don't forget to do your summary. And if it's too terribly confusing, watch the video again. Good luck.